Okay, let me give you a brief intro to the energy principle. This is referencing on the section 4.6 on the physics of plasma. So we first look at the second law of Newtonian mechanics. This is the mass density, and the C is the displacement, which can be think as the distance of the position where it's at. So if we take the Fourier component of it, then the ddt squared will become negative omega squared. We know that the kinetic energy can be written in this form. So this is velocity, and this is the mass density, and half mv squared integrated over the volume. And since we're taking the one Fourier component, then this thing become this multiplied by negative omega square, and this become that. And notice rho naught omega squared c, this thing is basically negative f. So substitute this whole thing with negative f, and negative 1 cancels out. Then we have a half f c dv. So just by looking at those two equations, those two expressions are equivalent. So what we can do is just take out the omega and put this, and this become a numerator, this become denominator, and we have this expression. So from the bottom we know that it's always positive because this is a square, absolute value square, and this is mass density. Mass density is always positive. Mass is always positive. So if this thing is positive, this integral is positive, then the right hand side is negative, which means this will be purely imaginary. This will be imaginary, which means the system is unstable. On the other hand, if this is negative, then or 0 is stable. So we can think in this way. So for stable case, f and c has opposite pointing in opposite direction, or not aligned in parallel in the same direction. So we can think it in a ball, and just if you go outward, the force will push it back into the equilibrium. So it's stable. One of the simplest example I can think of is a spring. So if you pull the mass outward a little bit, then the spring will make it go backward, and then it's oscillate, but it never diverge. So it's a stable system. On the other hand, if f and c is at the same direction, so if you nudge it out of the equilibrium a little bit, then the force is the same direction as the displacement, which means then they will encourage it moving forward even more. Then that will drive this system unstable. So one of the example might not be appropriate, but it is the simplest thing I can think of is a downhill. So it just keep going down, and it does keep accelerating. Of course, I can think of some relatively complex geometry and give you an example, but it will be relatively hard. You can think this is basically downhill this way, downhill that way, downhill all the directions. So basically an upside down ball, a ball, upside down ball, and you just nudge it out, and then it'll start to go outside. Go downhill, go down, become unstable.